So here comes the problems. So you're going to do some exercises here in a moment. I'll set you up for that here in a moment. But in your strategies and exercises for logical truth tables, really, it's very similar to what you did in truth tables before in regular programming. There are some differences. You have your overall logical connective symbols are a little bit different. By the way, we still haven't gone over biconditional, but you can think of implication as another gate. It's got its own crazy set of values that we're still going to get into more later on. So just think about it as the same construction that you had. So you would set up your basic variables in an overall set of your problem, kind of like what we did right about here. You know, if we have our equations a P, a Q, and an R, you're going to set up your table with those, and then you're going to follow the normal operations of precedence that you've done before. None of that really changes. It's just now, frankly, we got a new gate, if you want to call it, with our implication that we have in this problem right here. That's really about it. So what I want you to do, there's two problems. What's going to happen is that I'm going to show the first, you're going to see both of them here in a moment, but I'm going to reframe here and you're going to see the first problem. I want you to hit the pause button. Do the problem, only take you a minute or two, and then I'll go over a solution. And then I'm going to do the exact same thing for the second one. Whenever I do these problems, please hit pause. At least try it. If you get wrong, so what? I'm going over a solution and I'm going over why. Because these are going to show up, I can guarantee you, somewhere else. If you don't understand it, it'll be a different version, but still. So hit pause here in a moment. Once this pops up, it'll show you to hit pause. I'll go over a problem, go over a solution, then come back to the second one. Do the same exact thing. Here's our solution for part one. Now, we've already seen some of this before, so it's not meant to be super hard, but to be honest with you, this part's going to show up later on, and you'll be like, hey, I've seen that before, and now you know why. Well, I'll leave the rest to the next part. Let's go to the answer first. So we have our P and our Q, and as you know, especially if P implies Q, we got to make sure that the condition is true, then we need to make sure that we back it up with our Q and our response, so we don't break anything. Let's break any promises. So we have, this is the standard setup for P and Q. We have true and true, of course, did we break any promises? Nope, so we're good there. True and false, then we have our false here because we did end up breaking a promise, and then these last two are vacuously true. Now, by the power of editing here, I'm going to actually switch some things around and have P and Q just switch positions because I'm doing that because of frankly here. And it does actually make a difference when things turn out because you have true and true, which is first set up, but that's great. That's going to be true here. But on this one, notice that the P's and Q's are switched here. We're going to have a false and then a true. That's actually the old vacuously true when we had it in this order here. So that's going to be a vacuous true. Here we have a true and a false. This is the one where we actually break our promise, and again, in this particular order of Q and P. And then finally we have our last vacuously true because we have a true, well, we have false for both, so that's our vacuously true here. Then after that, you know how to do, well, frankly, an or from there on out. So here is the rest of our answers for that, and then we'll move on to number two here in a moment. Your table, but again, you've been through this before, so this is really nothing crazy that you haven't seen before. But notice I'm trying to be very painstakingly step by step on exactly how to get to our overall solution when we're said and done. So we have our P and Q. Notice I'm doing by order of precedence first, which is the negation first. So we're nodding our Q. And then because of the buildup of our situation here, we have our parentheses first. So I'm going to do our P and Q. You should have not negated Q, excuse me. So we have that. Then I'm going to worry about the other side, which is our P and Q. So again, looking at P and Q, and you'll see some magic here, some things disappearing and being X'd out here. We're going to have a true, we're going to have a false, false, and false, because it really the only thing it's for an and is two trues there. So anyway, then at the end, that's where the implication is. We got to go back to our implication tables of, hey, if it's both true or vacuously true, that's when we're going to have our true. So we have our false. Sorry about that. Let me do it this way. True and true, and we know that everything's been satisfied, so that's a true. We have a true and false. Uh-oh, we broke a promise. We have a false and false. That's vacuously true here, so that's going to be the true here. And then we have another true and another false, meaning that we broke our promise, so that's why that last one is false as well. So those are your two solutions for these problems. Let me know if you have any questions.